Excellent, excellent. Thank you very much. A real delight to be able to host the CTO of Microsoft, Kevin Scott, as our next speaker. I'm sure the discussion is going to be fascinating. I'm told that, Kevin, this may be the first time ever at an investor conference, a chief technology officer of the world's, I think, still the most valuable company. And I'll let Kevin jump into his intro in a second, but I have to share with you that a little-known piece of trivia. If we're talking about generative AI in such a big way, and if this thing has become such a mainstream thing, it was a magical meeting that was perhaps facilitated between Sam Altman and Satya Nadella by none other than my guest here. So we owe our interest in generative AI and how it's become such a mainstream thing to Kevin. So Kevin,
certainly not entirely.
in some part. So tell us a little bit about your background and how you got to be the CTO of Microsoft, and we have some questions to jump into.
Yeah, it's sort of a circuitous journey, but like the short story is I grew up in the 70s and 80s in rural Central Virginia. Like I was super lucky to come of age when the personal computing revolution was happening. Like I studied computer science. I thought I was going to be a college professor for a really long time. And then I left academia. I dropped out of my PhD program and joined this startup called Google in about a year before their IPO. I did a whole bunch of different things at Google. It was the place where I first built AI systems. So I did a bunch of stuff on both the search and the advertising side, like building large-scale machine learning systems. And like for a while ran the ads quality system. So like this big machine learning system that did CTR prediction for advertising, which was the thing that made the ad auction actually work.
I believe it's a small business these days.
Yeah, small business.
Yes.
And then I helped build this advertising company called AdMob. I left Google to do a startup, which got acquired by Google 3 years later. I was at Google for a while, and then I went to LinkedIn. I ran engineering and operations at LinkedIn, helped take the company public, and then I joined Microsoft when Satya acquired LinkedIn.
Mm-hmm. That's great. And you ended up as CTO of Microsoft. That's
very
quite
unlikely.
A story. Quite a story.
Unlikely.
Yeah. For someone who considered a PhD in English literature at some point in your life, this is quite a fascinating thing.
Yeah.
Kevin, can you share with us your view of where we are with generative AI today? How do you see it evolving over time? And is there at all a way to think about how this builds upon old AI that you developed at Google, if that's even a way to think about building one on top of the other?
Yeah, so I think we're still in relatively early innings. The interesting thing that's happened over the past decade in particular is AI systems have started behaving more like proper platforms. So like the first AI systems that I built were relatively narrow. So like if you wanted to solve a problem, like how do you calculate the effective CPM for an ad so you can rank them in an auction? You have a very narrow set of data about the ads and how people are clicking on them, and you use a relatively simple algorithm that's running at really big scale, and like you build a model and you run a bunch of experiments, and it's sort of a closed feedback loop, and the model gets better and better and better over time, but only at the narrow thing that you've trained it to do. And if you want to do a lot of machine learning, like in the past, like you had to have a whole bunch of different teams like running a bunch of those like little vertical loops. And I think the thing that has really started to accelerate over the past handful of years is like you have with generative AI these frontier models that really are quite useful for a huge variety of different tasks and applications and product contexts. Which means that you can think about them as a platform, like a database or like any other piece of infrastructure that you use to build things. It doesn't mean that you have zero work to do. Like there's still a non-trivial amount of work that you have to do to go make something valuable out of this bag of capabilities that is modern generative AI. And I still think, to a certain extent, the hardest part about all of this is like just having classic product sensibility, like understanding like what a customer need is and like what problem you're really solving, and then just attending to that with hair on fire urgency to try to do something valuable for somebody else. But the problem that you don't have right now is, the one that I had when I wrote my first machine learning program, which is I had to sit down and spend 6 months reading a bunch of papers and writing a bunch of really complicated code just so I could do a relatively basic thing. And that thing that was my first ML program in 2004, so depressingly long time ago, like a high school kid could do it in like 2 hours on a Saturday. I mean, it's just sort of shocking like how much capability is now in the hands of people who want to create new things with AI. And so like I think that's where we're at. And like the thing not to lose sight of, although like I really would encourage folks not to get too swept up in hype, but there is a very real thing happening with these AI systems where they're becoming like very much more powerful over time. And like I've said this a bunch of times in public, and I say it all the time internally. Like we are demonstrably not at the point of diminishing marginal returns on how capable these AI systems can get. And I think Dario was on stage, right before us. Like, I think all of the people who are sitting on the frontier, like evolving this particular new infrastructure, can really see that like there's still a lot of power yet to be built, and a lot of capability to be put into the hands of developers where, 5 years from now, 10 years from now, like somebody will be sitting on stage, telling some story about, the impossible thing that they couldn't do in 2024 that now a high school kid can do in a Saturday afternoon. I'm sure of.
That's where you see that things that we take for very complicated abilities become table stake.
Yeah, and it is, I mean, I know you all are investors, like I usually say this to like product makers. The thing that's going to be really interesting over the next handful of years is like seeing the companies and the entrepreneurs and the creative people sort of prospecting at that boundary of hard to, or like impossible to hard. I think in every platform shift that you get, whether it's the PC revolution, the internet revolution, the mobile revolution, the first things that happen is like you get this amazing new bag of capabilities and people go off and like build trivial things. And then they very quickly realize that things that have enduring value are like the things that are like just on the verge of impossible. Like they're ridiculously hard to do, but at least they're not impossible anymore. And like that's where the really interesting stuff lives. And like you can see it model generation by model generation, like things phase shifting from impossible to just hard. And like that's a good spot to focus your attention.
Got it. You've lived through a few tech cycles. So how do you compare and contrast this AI cycle that we're going through to internet, mobile, cloud?
Yeah, I think there are a lot of similarities to all of these big revolutions. Like it's sort of catalyzed by infrastructure. Like you've got a new thing that makes a whole bunch of things, possible that were, impossible or extremely difficult or costly before. Because like they're all platform revolutions, like they're not narrow, so it's not a thing that one company is doing. It's like, okay, like I've got some secret stash of infrastructure that only I have, and like only I can like imagine like what the possibilities of the infrastructure are. So like we just in parallel, like we have a huge community of people being inspired in a bunch of different ways by what the infrastructure is going to allow them to do, which I think is really, interesting and exciting and invigorating. Like the thing that, makes me happiest about like being in the spot that I'm in, is like seeing what creative people are going to choose to do with this. It also, you know, interestingly, I think all of these things have changed the way that software development happens. So it not only opens up new possibilities for what software can be developed, it also changes the means of production of software itself. So if you think about all of those previous revolutions, like you get a brand new tool set, and all of a sudden a type of software gets easier to write, and like you're just sort of excited as a software developer that like, oh my God, like now I've got this thing, and like it just, like all of this stuff that irritated me before is like easier now. And so like those two things, you know, constructively interfere with one another. So like you're off chasing new ideas, but like you're chasing it with a tool set that's made you more productive than you were before. And so like that's truly an exciting moment to be in. And like, you know, we'll sort of see over the, you know, the coming years, that these are things that are very hard to predict, but all of this may be happening faster than what we saw in the previous revolutions. But like, you know, one thing that's relatively certain, like if you sort of believe that we're in a big platform shift, you know, trillion-dollar companies that are brand new are getting created right now. And like usually like the folks who move early, like latch onto the possibility, like get into that learning loop where they are, you know, experimenting and learning and, you know, understanding, you know, like what the valuable is versus what the trivial is, like are the ones who like have real advantages in, you know, building those durable, super valuable things.
Got it. If this question sounds very intelligent, it is because Marco Argenti, our CIO, asked me to ask this question of you. I wish he'd been here sitting on stage with you, but he has another commitment. It goes like this. We've seen exponential improvements in LLM models so far.
Yep.
There's a race for attributes, parameters, modes, and data size. Is the rate of change slowing down? Is this generation of models the path to AGI, or do we need a fundamentally different evolution of the transformer architecture to continue making progress towards that goal? So clearly that question did not come from me. Marco, thank you, in case you read the transcript of this.
Yeah, I mean, again, you all will have to be the judge of this over the coming weeks or months, but like, you know, I think there's some super exciting things that are coming in the, you know, last half of this year that, you know, lots of folks have been working super hard on. I don't see, I've said over and over again, like I don't think we're at the point of diminishing marginal returns on the current paradigm. Like I think we have a pretty clear path to like building infrastructure that is like stays on the same, you know, path of performance gains that we've seen, and like on multiple dimensions. So like its capability, its cost, it's like, you know, sort of power performance of systems. It's like, you know, just sort of a bunch of things, and like an entire ecosystem of really smart people like tackling all of the different parts at all the layers of the stack, just trying to improve things. I mean, that said, like you are not wrong to suggest that there probably are some disruptive innovations that will change things again. Like we should hope for it. Like I hope the transformer is not the last interesting discovery in ML architectures. Like I hope not. And like, you know, we even have a proof point. Like we all have a 20-watt AGI machine sitting between our ears, which is dramatically more efficient than like the things that we're building right now. So like you should hope that, you know, we make some discoveries over the intervening years that bridge the gap between what we're doing and what biology knows how to do. But like the things are not independent. Like we're not. At least from what I can see, like we're not at the point where we're about to stall on progress of the, you know, increasing the capability of the infrastructure because like we don't have the next idea for, you know, what needs to be done to make it more powerful.
Got it. There's been a lot of talk about small language models versus large language models and the role and the relative positioning of these two. How do you shake out on this SLM versus LLM? And a follow-up question to that I wanted to ask about open source. Where does open source fit into all this as well?
Yeah, like I mean, like we can sort of like start with the fundamental principle that I think answers them both. Like I'm pro-developer. Like I think do whatever you need to do to like get the interesting application written, so that you can do something someone cares about. Like being dogmatic about what tool you use to solve a problem is kind of nuts. And like you can practice a bunch of wishful thinking about like what you would like developers to do, but I'm sure you all know developers, like they're the orneriest people on the planet, like highly opinionated, and like they're gonna experiment with a bunch of different things, and like they will choose the tool that makes the most sense for them to solve the problem that they're trying to solve. So in that sense, like, you even look at Microsoft developers building copilots, like the way that a copilot is architected is that you are typically using a frontier model to do the bulk of the interesting work there, but like you also use a bunch of smaller models in parallel. Like you have a fairly robust orchestration layer that decides how to route requests to which model to let you achieve the performance that you need on a bunch of different dimensions for the application you're trying to write. Like sometimes like you need like to send something to a small model because you're not going to get a better answer from the large model, and it's just much cheaper or much faster to like make the inference request to the small thing. Like sometimes like you're trying to do something on device locally, like you can't afford a network call into the cloud to invoke a large model. And so like I think having that flexibility to architect the actual AI applications using the right mix of models is like an important thing for developers to be able to have. But like the large models are very important, and like they are the things that are, I mean, they sit on the frontier. And so, again, if you are looking at building the most ambitious thing possible, like I think need to have one of them in your portfolio of tools so that you can be attempting only the things that they enable. Mm-hmm. But it's not a dichotomy, like not an either or. Mm-hmm. And same thing with open source. Like I think open source is like just making tremendous progress. Mm-hmm. Like it's super encouraging, like as a developer, I think, to see how fast the open source community is building really interesting things. And like, there are a bunch of people at Microsoft and Microsoft Research inside of my team who are building things like Phi, which is like a really capable SLM. And it's open source, for folks to use as they choose. And again, with developers, like they want choice, like they want to be able to experiment, like they don't want to be told, what their tool set is. They want to be able to experiment and choose. Got it. So at Goldman, we have this acronym IPA: infrastructure, build out, then platforms and applications. That's where we've seen other computing cycles more or less evolve. Do you see that as a similar way in which generative AI progresses, or am I hallucinating? Yeah, look, I think so. What I'm seeing right now, and this is the place where it is like a really unusual revolution. So, like you definitely have like these things that are sort of independent of one another execution-wise. So, like, there's a bunch of infrastructure stuff that you need to go, like pour concrete, like sign leases, like get power in place, solve a bunch of electrical engineering problems, solve a bunch of cooling problems, like get the right silicon in the right places, design the network fabrics, and all of these things operate on different timelines. And then you have the software stack that sits on top of that, like your low-level systems layer, and then you have like your middleware and applications stacks that sit on top of that. Things are moving so fast right now that it is kind of hard to imagine a world where you like go do the infrastructure build out and you wait until it's done until you make the substantial decisions and deployments on the next layer up. So all of this stuff is, really feeding into each other in a way that I haven't quite seen before, like where you are just making big decisions on things that really want to move super slow, but where you have to make them move fast because like the technology is just sort of evolving at such an incredible pace. It's really, really interesting. And like, I will say, like, I think you guys have Jensen coming on later. Like,
tomorrow morning, yeah.
Yeah, I mean, yeah, everybody in the ecosystem is moving materially faster right now than they were 3 or 4 years ago. Materially faster.
Is it because the science and the technology is moving rapidly, or is it, what is driving that?
I think it's a feedback loop. I think you've got a bunch of really smart people who can respond very well to urgency. And like the place that we're in right now with infrastructure is, people ask all the time, like, are you building too much or building too little? And so far, it's
that's what they want to know. Yeah, we're building too fast, too quickly. How much we're going to spend?
Dude, I want to know it too. But like, so far, demand for the infrastructure has materially outpaced our ability to supply it. And so, like, we are building at a pace where, based on our understanding of where, demand is going to be, like, we're trying to sort of intercept things that, like I just said, like, there are a bunch of slow-moving things in the equation that, like, we've just really had to try to make move much, much faster than they were moving before. And like, the thing that I will say is, like, I think the whole ecosystem is responding incredibly well. Do I wish it were faster? Yes, I wish it were faster. But like, thank God it's so much faster than it was like 4 years ago, because we would really be in a pickle then.
Got it. Generally, I want to get your views on compute costs. Generally, with tech cycles, the underlying inputs become cheaper. We have mass market, standardization, et cetera. How important, given the high cost of compute here, how important do you think it is to bring down compute costs? And if you think it is, what are the developments that might support that view?
Yeah, so it's super important always to bring down the cost of compute. Like, one of the things that has supported all of these platform revolutions that we talked about, personal computing, internet, smartphone, cloud, all of them, has been this ability from silicon to networks to, like, the low-level software layers that empower the layers running on top of them to get exponentially cheaper over time. And I think we are definitely seeing that. Like, I don't know exactly what the number is right now, but back in May when I was giving my keynote at Build, the anecdote that we gave the audience was at that point in time, GPT-4 had gotten 12 times cheaper, like, per token to do inference on than at launch time. And so part of that is because the hardware had gotten a lot better, and, like, part of it is because the infrastructure had been tuned within an inch of its life. Everything from numeric kernels where people are writing the moral equivalent of a bunch of assembly code to, like, extract every ounce of performance out of the chips that you've got. And then, like, just foundational improvements to the algorithms that are running on top of the like, hardware layer. And I think this is just going to continue over time. So, like, the important thing to realize is things are already, like, getting, on a price performance basis, like, way cheaper than they were. And, like, there's super good stuff coming, like, from, hardware to system software to algorithms that should keep that trend moving. And, like, we just got to keep pushing super hard on it, because, like, if you really, really want all of this stuff to be ubiquitous, like, you need it to be as cheap as possible so everyone can use as much of it as makes sense.
Kevin, you piqued my interest by saying super good stuff coming. So to the extent that you can share with it, what is the high level super conceptually, maybe the things that are giving you that conviction?
unfortunately very little that I can.
Okay, that's all right. I don't want to create any problems. So we'll just take that as a granted.
Yeah, if we were off the record, like I can share. But so look, I think the thing that ought to give everyone, like we'll have things that are coming shortly that'll be super visible that I think will be very encouraging for people looking for signs of progress. But like you can just even looking at what's happening on a week by week basis is like all of this competition is happening where Meta's doing great stuff with Llama, and Anthropic is doing super good stuff, and Google is doing. I mean, so there are these objective benchmarks for how everyone is performing, and like people, because of competition and because the science and the sort of engineering is happening at such an incredible pace, like just every week things are getting better. And like the point that I've the point that I have been trying to make for a while to all of the folks inside of Microsoft is like there is a weird nature of how the frontier progresses, which is like you go build gigantic supercomputing environments, which are like big capital projects that take a very long time to build. And then you put them in the hands of people who are going to train a frontier model on them. And then, they optimize their workload on that environment, and then they do this extraordinary work. And then like you get a new frontier model. And like, because of the nature of the way all of this unrolls is like you're just applying dramatically more compute to the to the problem, and it just happens in these like increments because of the way that you're building all of the systems. And so the thing that people forget sometimes is like between the updates, like you can get into this mode where you've convinced yourself, well, like progress is only linear, like this benchmark only got this much better, and you sort of forget that, like you look at our partner, OpenAI, like what the big updates have been, like the jump from GPT-2 to 3 and from 3 to 4. And, like I can't say anything about like what's next and when, but like it's not like work stopped after GPT-4. So, the thing that we have seen for the past 6 years with generative AI is like every couple of years or so, just because of the lockstep way that all of this stuff gets built, like you get a major new update to the frontier.
So Brett and Kendra, we'd love to, when he's ready to officially announce the good stuff, we'll love to host you back at our Goldman Sachs AI Symposium. Just putting it out there. Always putting a plug for the firm. How dependent is your AI strategy on OpenAI? Because you also have your internal AI with the CEO of AI. How do these things work with each other?
I think OpenAI, like by any objective measure, has been one of the most consequential partnerships Microsoft has ever had. And like we're a company that's had a lot of consequential partners. So like we're super grateful, and like I think we've been able to do things in a pretty extraordinary way just because it's like two really capable companies like trying to push a big platform shift forward rather than like one trying to do everything. So like like we don't even think about it in to say like we're sort of super dependent, and like it's a complicated bag of problems that we're collectively trying to solve. And just like with the PC revolution where you had Microsoft and Intel and like a whole bunch of OEMs like doing this. I mean, you just sort of think about like this is before my time at Microsoft. I've only been there for like a little under 8 years now. The mission of the company since like at the point where it was founded was to put a personal computer on every desk and in every house. And like that's at the time where people didn't even know what a personal computer was. And so through that partnership, like the entire ecosystem was able to deliver that mission, which is like just completely audacious. And I think this is another, mission, like, really unlocking the full potential of AI to create value for people everywhere is another, like, equally large thing. Like, I just don't think it gets done by, like, one entity. It's a lot of people working very hard in the same direction.
And hence, that's why you have your own AI CEO internally, and then you have...
We do. Like, I mean, Microsoft has had, like, AI researchers, working on AI since the 1990s. Like, we were working on artificial intelligence when I was an intern at Microsoft Research in 2001.
You were an intern at Microsoft Research?
Yeah, dude, yeah. Microsoft Research reports to me now, and 23 years ago, I was an intern at Microsoft Research.
Any intern at Goldman Sachs, just take that as an inspiration.
But like, so there's a lot of AI that Microsoft is doing that is, like, very complementary to what OpenAI is doing. And we were doing it before. It's going to continue, for the foreseeable future, because, like, it's a really large surface area. There are a lot of problems that need solving.
Good to know that. Good to know that. This, again, I'll preamble this saying, this is a Marco Argenti question. So it's going to sound very erudite, right, Belinda? We seem to be moving chatbots to agents very quickly. What's the vision with regards to AI performing more and more complex, long-running tasks? Do we see a future where AI-powered agents will be able to perform tasks that require planning, decision-making, and execution across multiple environments and systems? This man, what a beautiful question. It's like poetry, right?
Yeah.
So that's why I had to give credit to Marco. Nobody can.
The answer to the question is yes, and I guess why do I believe that?
Yeah.
So look, I think one is, like, it's just necessity. So in order for AI systems to be fully useful, like, they do need to be able to do longer term planning. They need to have memory. They need to be able to actuate, like, products and services and interfaces on behalf of users. And I think there's a bunch of good work that's been happening, on everything from orchestration layers, where, like, you're giving developers, like, really good frameworks for figuring out how to uplift the basic capabilities of models to, like, help them do more of, this sort of long-range, like, multi-step task. And then the models themselves, I think, are getting, like, more capable of synthesizing plans on their own. I mean, you can even see a little bit of this, like, if you go to ChatGPT right now and you ask it to, like, give you a plan for something, like, it can articulate, like, pretty comprehensive plans for very complicated things. And so, like, the next thing that you would want after that is for the agent to be able to say, like, okay, like, I see the plan, go do that. And I think that's
What's next.
Yeah, I think lots of people are working on filling out that hole in the capability of these systems. So yeah, I think lots of good stuff coming on that front.
Got it. We have 2 minutes. I don't have any more questions. Is there a question that you want to create yourself an answer for yourself?
Oh, God.
You're a prompt engineer, right? I mean, so...
Yeah. I don't know. So I think it's not necessarily a question, but just a thing that I will leave everyone with. Like, I think the thing that we've seen over and over again with building hard things is you want to strike the right point between aggressive pessimism and aggressive optimism. Like, you just don't want to get yourself caught up in hype in either direction. So the thing that we like inside of Microsoft is, like, we're trying to do very hard things with these very complicated models is you want teams to be as ambitious as humanly possible in how they're putting this stuff to work. Like, you really want to find the things that are like just went from impossible to hard. Like, you probably don't want to like spend a whole bunch of your energy doing a bunch of incremental things, because like optimizing an incremental thing when like the underlying model infrastructure is getting more and more powerful so quickly, like probably means that the model is going to be able to do a whole bunch of this incremental stuff. And like this was the lesson we learned years ago, like in the very, very early days of our partnership with OpenAI. Like I would have teams inside of Microsoft that would like take GPT-3 and they would go build this fine-tuned, like super optimized thing, and it was like, 3% better than it on some benchmark and like a little bit cheaper. And they were like, yay, victory. And then GPT-4 came, and it's like, crap.
Yeah.
Like what do we do now?
Better, yeah.
Yeah, so you want to be on the frontier with your ambitions. Yeah. And like it's a good spot to be.
It's great. We are right at the top of our allocated time. On that note, thank you so much for giving us a perspective.